Hi, today we're going to compare standard machining to iMachining for aluminum. We want to show that even with aluminum machining, where we cut at very fast RPMs and very fast feed rates, iMachining is still giving a faster overall cycle time for roughing, rest roughing, and finishing. So what we have here is we have a aluminum aerospace part. It is basically a 3-axis part, minus the outside cut has a 5-axis taper to it. We'll run through the simulation first on the standard cuts, and we'll take a look at what we're comparing. We'll move to our solid verify. Now the first thing we do is we're going to rough out the outside. We'll take a look at the part as we're going through the simulation. So the first cut is roughing the outside shape from the aluminum stock. After that, we move to the center pockets. You can see going from the left pocket to the middle pocket, and then to the right pocket. After that, we're going to machine the center through hole. After we're done roughing, we're going to use a smaller end mill to finish the walls on the inside pockets. After that, we're going to now use a 5-axis swarf cut to finish the outside tapered surfaces, as we see here. And then finally, when this is done, we're just going to have a simple drilling operation to put in these 4 197 diameter holes. As shown. So now let's go compare what we have. What we're using is we're using 3 tools to do this. We're using a 3/4 inch with a 125 corner radius 2-flute carbide end mill, as we can see on my mouse. We're using that for the bulk roughing. We are then using a 1/2 inch with a 125 corner radius to finish. This is to finish the outside and to finish the inside. And then finally, we're just using a 197 drill to finish the 3 holes, or the 4 holes. Now let's compare what we're doing with standard pocketing. The first operation, we're doing a 200,000th depth of cut. Our feed rate for this is we're going 8,000 RPM at 100 inches a minute. If we go to our second cut for the center pockets, using the same tool, same feed and speed, 8,000 RPM, 100 inches a minute, and we're doing the same 200 thousandths. In this operation, we're also finishing the floor with the bowl mill, so we have a 15 thousandths floor offset, and we are finishing with the same tool. For the center hole, we are doing the same 8,000 RPM. The only difference here is we're also finishing the wall. When we are finishing the inside pockets, we're switching to the 1/2 inch end mill. We're still sticking with the same 8,000 RPMs and 100 inches a minute. When we go to our technology, we're doing a 200,000 step down still. However, we are doing a rough and a finish at the same time. Because of the excess material left over in all the corners, we can't just go right to finish size. We have to take a rough cut, which is 5 thousandths away, and then a finish pass, which is to size. And if we go to the solid verify and take a look at this, it'll be quite clear what's happening. So as we zoom into this one pocket here, and we single step through, and we'll just do one level, we can see that in some of the corners we have excess material from the larger tool. On the straight walls, of course, we only have our 10 thousandths wall offset that we define. But because of that, we want to do a rough and finish to bring that wall into size. The 5-axis swarf cut is doing the same thing as the pocketing. It's a 200,000 step down, 8,000 RPMs, 100 inches a minute, and the drilling is working at, I believe, 2,000 RPMs and 15 inches a minute with a straight peck. Now, what we want to compare is what's the difference between iMachining and standard pocketing. So if we look at the standard pocketing toolpath, We can see we have multiple step downs, the 200,000ths, and our step over. We see many repositions to continue with climb cutting. If we look at that same cut with iMachining, what we see is no retracts. In iMachining, we're also going full depth of cut. We are doing a smaller step over because we're going deeper. However, the tool is staying engaged longer. If we go and look at the feed rates that we're running here, we're running a little less than 7,000 RPM, so a little bit less than the standard pocketing, and we're running 100 inches a minute. Those are the values generated from the wizard. If we look at the inside pockets, you can see we have our standard offset style strategy, once again doing multiple step downs. If we go to the iMachining strategy, we're doing a singular step down once again. We have our helical entry, just like the standard pocketing. Both are using the same helical angle, 5-degree entry ramping. Here, the difference here is we have, as we see with iMachining, one step down, very few repositionings. We're running the same feed rate again as the roughing, less than 7,000 RPMs and roughly 100 inches a minute. If we look at the roughing of the center hole, basically the same between the roughing of the previous operations. Now the finishing, this is where things get a little interesting. If we look at the profiling operation, as we see we have double passes around the entire part to try and achieve our rough and finish. When we look at iMachining and iFinish, we do something very special here. What we do is we analyze the entire geometry. We look at where the leftover materials. As we see here, we have our parent operation, which was the rough pockets. It knows the previous tool, wall offset, and fillet radius. And what we do is we analyze where there's excess material. What we're trying to achieve is a final finish pass around the entire contour that is just removing the wall offset. So if we were to go and look at this toolpath, what we're going to see is any of the corners that would have had the toolpath being over-engaged, we are now finishing those areas first with a roughing toolpath. So we see the corner here, the corner here. As we look at the large corners, where the tool would be able to still take the wall offset in one final pass, there's no toolpath. So the difference between here is iMachining is able to intelligently analyze the contour, machine just the areas it needs to first to prepare for one single step down at the end. This is very unique to iMachining. No other software has this. This allows us to take one final pass at full depth of cut because we know we're getting full stability with the end mill and that the tool is not going to get over engaged in any of the corners because iMachining took care of it. We can go take a look at the simulation and see what's the difference between iMachining and the standard pocketing. We'll reorder these operations so we don't have to simulate them. Go to our solid verify. Once again, let's look at our part while the simulation is going. So with iMachining, you can see it progressively shave the stock away from the outside. As we see it do the center pockets, we see it helical enter, and then we see it clear away the material at full depth of cut. Working from the left pocket to the center pocket, and then finally to the right pocket. As we can see, progressively shaving away the material the entire time. We still have the finishing pass that we're using with the iMachining, same as we did with the standard pocketing. After the three main pockets are roughed, we're then going to switch over and do the center hole. And let's slow up and watch the iFinish toolpath work with the smaller half-inch tool. What we're going to see is it clears out the corners and gives one final preparation pass. And as we had with the standard, we're still using a 5-axis swerve cut to finish the outside. Now for the nuts and bolts of what time savings do we get. We have prepared a simple Excel document to explain the difference. So we have our 4 cuts roughing the OD, the pockets, the center hole, and the finish pockets. And then we also have our 5-axis swerve cut and our drilling. We're using the same strategies for both, so we have the same times listed, and we're not talking about RPMs and feed rates. What we have is we have listed our standard RPM and iMachining RPM. Same with feed rate, depth of cut, and cycle time. As we can see, in standard we're actually using a little bit more RPM for the larger tool than what we're using in iMachining. On the finishing, we're using a little bit more RPM. When we look at the feed rates, generally we're looking at almost similar feed rates, 100 inches a minute, little difference here and there, but generally the same feed rates. The big difference we see here is in our depth of cuts. With the standard pocketing, we're using 200 thou depth cuts for everything. In iMachining, we're going full depth of cut for all of them. As we see our cycle times here, the roughing from the OD went from 8 minutes to 1 minute and 30 seconds. When we did the center pockets, not as much repositioning from the standard pocketing, so it went from 7 minutes to 3.5 minutes, still almost a double increase. On the roughing in the center hole, 50 seconds to 25. A big difference we see here is with finishing, and this is where we think iMachining definitely has a huge advantage over all other toolpaths on the market and all other CAM solutions. With finishing technology built into iMachining, it's not only made for roughing. Here we see took a 2 minute and 27 second toolpath down to 35 seconds. This was easy, and it was all done by iMachining. It automatically analyzed the contour, found the overengaged areas, and then took them out first to do one final toolpath at the end. What this left us with is a 22-minute cycle time for the standard and a 9-minute and roughly 50-second cycle time. This gave us a total decrease in cycle time of almost 60%. For all of us machinists, as we know, $65 an hour for our machine rate, we're able to get twice as many parts done, even in aluminum, on a standard Haas. None of these RPMs are talking about machining on Machinos or microns or anything. This is just standard 10,000 RPM Haas VF2 with a 5-axis trunnion. These are the type of savings we can see in aluminum with standard cutting versus iMachining.